everyone. Let us begin our Python fundamentals learning journey by introducing how the computer architecture is capable of handling the different software and hardwares along with the external memory or input and output devices. Here is the simple architecture of any computer irrespective of its processor. Here we can see the different parts of the computer like CPU along with the main memory like RAM. This forms the main heart of the computer. Next we have input and output devices like keyboard, mouse, mic, speakers, pen drive, monitors or screen, etc. Secondary memory consists of external hard disks, external storage devices like SSD, etc. Suppose if we want to interact with the computer, a computer can't directly interact with the human readable language, either text, speech or program, or a set of instructions to do a specific task. Then how it will do the work? It will do all the work using a software and the processor. Softwares are written using either a medium or high-level programming languages, whereas the computer processor, which first converts this high-level programming language into a machine-readable low-level language and then try to interact to give an output as per the instructions or software which are used by the humans to interact with the computer. So, we came to know that there exist different types of computer languages. So, let us see one by one in simple, and at the end we will come to know why we need different programming languages and softwares which are written by the different kinds of high-level programming languages like Python, because Python is a high-level programming language. First, let us see the definition of a programming language. Programming languages define and compile a set of instructions for the CPU for performing any specific task. Every programming language has a set of keywords along with syntax that it uses for creating instructions. Firstly, the programming languages are divided into two major categories, namely high-level and low-level languages. What are high-level languages? High-level programming languages offer a higher level of abstraction, meaning they are further from machine code and closer to human language. The instructions for the program are written in English, for example, print, input, etc. These high-level programming languages are further classified into procedural languages and non-procedural languages, and finally object-oriented programming languages. Procedural programming is based on the concept of a set of procedure calls. A programmer writing program in this language can precisely define a series of actions in order to perform a specific job. Languages that display step-by-step algorithms written to work a problem are identified as procedural languages. Examples of procedural languages are Fortran, COBOL, C language, Pascal, and BASIC. Non-procedural languages, also known as declarative languages, do not require writing traditional programming logic. The instructions are not written in a specific order, hence writing language of this kind is easy. Examples of non-procedural languages are SQL, Prolog, and Lisp. Object-oriented programming languages. Object-oriented programming languages use objects that include both code and data. It includes logical classes, objects, methods, relationships, and other processes for building software and applications. Popular object-oriented programming languages include Java, C++, Python, and Smalltalk. Next, we have low-level languages. Low-level languages are the opposite side of high-level languages. They provide low levels of abstraction, that is, binary code. These programming languages are more difficult to learn and use, but contribute more functionality and direct command over the machine. The low-level programming languages are further classified into machine languages and assembly languages. Machine language is the closest language to the hardware. It comprises a collection of instructions that are performed directly by the computer. These instructions are a series of binary bits, that is, zeros and ones. Every instruction performs a very particular and minute task. Instructions written in machine language are machine dependent and differ from computer to computer. In simple words, we can say that machine language is the system language or CPU, which understands a language is nothing but machine language. You can see the machine language how it looks here, in the form of ones and zeros. Assembly language is an advancement over machine language. Unlike machine language, assembly language also communicates straight with the hardware. Rather than using raw binary bits to denote an instruction, assembly language uses mnemonics. Mnemonics are short abbreviated English words used to name a specific instruction given to the computer. Each instruction in binary has a unique mnemonic. These mnemonics are architecture dependent. Hence, there is a list of separate mnemonics for each computer architecture. Assembly language uses a special program called assembler that translates mnemonics to particular machine code. Let us see the advantages and disadvantages of high-level and low-level languages. Advantages of high-level languages. These are simple to use and understand. High-level languages use words closer to the natural language and thus are easier to learn and understand. Machine independent. Programs written in a high-level language are compact and can be executed on any kind of computer with slight or no alteration of code at all. Easy debugging. The use of these languages makes it easier to write a program and debug it while giving the developer some time to go over the entire logic of the program than just thinking about the code. The errors can be detected easily as these languages use compilers and interpreters. If we talk about the disadvantages of high-level languages, poor control on hardware. Assessing and controlling the hardware is hard since high-level languages are away from the hardware. Slow execution. Programs written in high-level language should be translated to machine language. The process of translation increases the time of execution. Let us see the advantages of low-level languages. They are fast to run as specific translator is not required. The second advantage is they are simple and machines can understand as they are related to hardware. Third advantage is the programmer has unrestricted access to the functioning of a computer system. If we talk about the disadvantages of low-level languages, the first disadvantage is it is nearly impossible to find and rectify the issues. The second disadvantage is time-taking. And the third, they are costly. And finally, difficult to program. So these are the advantages and disadvantages of high-level and low-level languages. Let us see the major difference between the high-level and low-level languages. The high-level languages are programmer-friendly, whereas the low-level languages are machine-friendly. High-level languages are less memory efficient, whereas low-level languages are highly memory efficient. High-level languages are easy to understand for programmers, whereas in case of low-level language, tough to understand for programmers. We can easily debug the high-level languages, but it is complex to debug comparatively with respect to the low-level languages. High-level languages can be maintained easily, but low-level languages cannot be maintained easily. High-level languages are portable, whereas low-level languages are non-portable. High-level languages can run on any platform, but low-level languages are machine-dependent. High-level languages needs compiler or interpreter for translation. Low-level languages needs assembler for translation. High-level languages widely used for programming, whereas the low-level languages not commonly used in programming. Let us see what are the uses of high-level programming languages by their use. These high-level languages can be used in commercial software development. They can be used in user-friendly computer applications development. They are using in game development. They are using in website development. They are using in website maintenance. They are using in Android app development. They are using to control machine actions and performance. They are using in banking server management and maintenance. Strictly, if we talk about the applications, it may take a separate section. In fact, almost all the computer applications what we are using, including MS Office, Paint, operating systems, etc., are all created using one or the other forms of high-level programming languages, or with the help of low-level and high-level programming languages. We end our explanation on different use cases of high-level programming languages. So, both low-level and high-level programming languages are together combining to form a complete computer software. Or, in other words, in simple, we can say that low-level languages are necessary to build and operate with the high-level languages. Software developers are classifying these programming languages in different ways in modern days. They are nothing but front-end programming languages and back-end programming languages. Some of the top programming languages for front-end development are HTML, CSS, JavaScript, React, and Vue. And the few best programming languages for the back-end development are Python, Golang, PHP, JavaScript, Java. Here we can see how the hardware, machine language or low-level language, assembly language and high-level languages are having the relationships with each other. As we said earlier that we can't interact directly to talk to the machine with its low-level language. Means the actual hardware inside the central processing unit, that is CPU, does not understand any of these high-level language or high-level programming languages. For that, we need translators. Translators are the language converters and they allow programmers to write in high-level languages like Python or JavaScript and convert the programs to machine languages for actual execution by the CPU. Translators are generally of two types, interpreters and compilers. An interpreter is a translator which reads the source code of the program as written by the programmer parses the source code and interprets the instructions on the fly. Python is an interpreter, and when we are running Python interactively, we can type a line of Python, and Python processes it immediately and is ready for us to type another line of code. It is the nature of an interpreter to be able to have an interactive conversation. The Python interpreter is written in high-level language called C. A compiler is a translator which handles the entire program in a line, and then it runs a process to translate the high-level source code into machine language and then puts the resulting machine language into a file for later execution. So, Python is an interpreter. It would use a just-in-time compiler. Here we can see how Python is interpreted. An interpreter is also a kind of program that executes other programs. When you write Python programs, it converts source code written by the developer into intermediate language, which is again translated into the native language or machine language that is executed. A compiler is a special program that processes statements written in a particular programming language and turns them into machine language or code that a computer's processor uses. How can we relate interpreted and compiled languages? An interpreted language is any programming language that is not already in machine code prior to runtime. Unlike compiled languages, an interpreted language's translation does not happen beforehand. Translation occurs at the same time as the program is being executed. In other words, a compiler is a piece of code that translates the high-level language into machine language. Interpreter also convert the high-level language into machine readable binary equivalents. Each time when an interpreter gets high-level language code to be executed, it converts the code into an intermediate code before converting it into the machine code. So, this is how the Python interpreter works, and how the compiler works, and how the interpreter works separately. Many learners ask some questions related to interpreters and compilers. They are nothing but how Python is interpreted, how compiler works, how can we relate interpreted and compiled language. Let us see the answer one by one. Let us see the difference between interpreted and compiled programming languages. On the left side, you can see the compiled languages, and on the right side, you can see the interpreted languages. A compiled language is a programming language whose implementations are typically compilers and not interpreters. Whereas, in case of interpreter, an interpreted language is a programming language whose implementations execute instructions directly and freely, without previously compiling a program into machine language instructions. In compiler, in this language, once the program is compiled, it is expressed in the instructions of the target machine. In case of interpreter, while in this language, the instructions are not directly executed by the target machine. In compilers, there are at least two steps to get from source code to execution. In interpreter, there is only one step to get from source code to execution. In compiler, in this language, compiled programs run faster than interpreted programs. In interpreter language, while in this language, interpreted programs can be modified while the program is running. In compiled language, compilation errors prevent the code from compiling, whereas in interpreted languages, all the debugging occurs at runtime. The code of compiled language can be executed directly by the computer's CPU. A program written in an interpreted language is not compiled, it is interpreted. In compiled language, it delivers better performance. Interpreted language delivers relatively slower performance. Examples of the compiled languages include C, C++, C#, COBOL, etc. Examples of the interpreted language includes JavaScript, Perl, Python, Basic, etc. In the next session, we will see how the compilation takes place behind the scene in Python.